Do just some more work with these absolute value equations. And this is a more specific absolute value equation where we have an absolute value term, but we have other x's or other terms in here. So it's not the absolute value equal to a number like what we worked on last week. Now we have the absolute value expression equal to, I would consider this a linear expression. And so the solving and what we have to do to make sure our answers are correct are just a little bit different. So I'm going to have you just start by jotting down this equation. And then one thing that it says in our directions is it says check for extraneous solutions. An extraneous solution is an answer that we solve for, but it's not actually a solution. So it feels weird because you're like, I get this answer, but it doesn't actually make the equation true. So an extraneous solution is a solution we get from solving but it actually does not make equation true. And so how we're going to catch that is we're going to actually check our work. Once we come up with x values, we'll plug them back in and see what we get. And for now, I'll tell you to check for extraneous. As we progress in this curriculum, we'll have to kind of think about when are times that we maybe need to check for an extraneous solution. For now, I'll just tell you. Okay, so the way that we start, let's pretend that this is absolute value of 3x plus 2 equal to 5. And I'm just going to write that. You don't need to necessarily write this down, but I'm going to pretend that I started here. Because once we get the absolute value term equal to a number, or equal, basically a better way to think about this, once we get the absolute value term isolated, then we split this up, where the absolute value term stays the same, and we set it equal to positive or negative of the other side. Well, that's the exact same thing we're going to do to solve this equation here. It's just the right side is not a number. It's a full-on expression. So with this equation, the absolute value of 3x plus 2 equal to 4x plus 5, I'm going to do the same thing. I'm going to just drop my absolute value brackets. So 3x plus 2 is equal to 4x plus 5. And then I'm going to set another 3x plus 2 equal to the negative value of that right side. So the one thing that we need to add in are the parentheses and the negative out in front, because everything in that is going to get a different sign. And now from here, we just solve all the same. Okay, so it really isn't much different than when we have the absolute value equal to a number. At least not yet. All right, so to solve, I'd subtract 3x. I get 1x. Subtract 5 and get x equals negative 3. On the right side, I'm going to distribute this negative. So I get 3x plus 2 is equal to negative 4x minus 5. I'm going to add 4x to get 7x, minus 2 to get negative 7, and get the x equals negative 1. So in our solving, we got negative 3 and negative 1. Everything in the work we did makes sense, okay, leads us to these answers, which, again, seem like correct values. But now we need to check them, because it is possible that one or even both of these answers does not actually make the equation true, and thus they are extraneous. So we're going to check these. So I'm going to sub negative 3 back into the equation. So 3, negative 3 plus 2, is that equal to 4 times negative 3 plus 5? I don't need that. So this would be negative 9 plus 2. This is negative 12 plus 5. So this is the absolute value of negative 7 equals negative 7, but the absolute value of negative 7 is positive 7. So in our checking, I'm finding that this is not a true statement. When I plug in negative 3, it's almost true, but I'm ending with 7 equaling negative 7, which is a false statement. So what that tells us is this particular solution of negative 3 is extraneous. Meaning all of our work led us to find that answer, but it does not actually make the equation true when we plug it back in and check it. Let's just make sure that that does not happen with negative 1. So this is absolute value of 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. So absolute value of negative 3 plus 2, negative 4 plus 5, that's 1. Absolute value of negative 1 is 1, and negative 4 plus 5 is also 1. So in this case, since we end with a true statement, that tells us that negative 1 is an actual solution. So when you're doing your work, okay, what I'm looking for is just the final solution or solutions. And in this case, the only one that is a solution is negative 1. You don't need to explicitly tell me that negative 3 is extraneous, but you do need to identify that it is in fact not a solution. So doing this whole process is how we're going to catch that. Solve it, check it, and then decide if any of the solutions are extraneous. Okay. Any questions about how I'm coming up with either x value or just the idea of an extraneous solution? Okay, I'm going to have you all solve one more on your own, and then we'll jump into the assignment after this. This is the last thing I have you all done. A couple minutes, work through the next one, check with your group as you go. All right, one thing that I want to point out here, and then I'll let y'all get working. Shh. Hey, quiet, please. When you do this first step, so after you isolate the absolute value brackets, then you're going to go ahead and drop them. Notice how when I make my two equations here, there aren't any absolute value brackets around the 5x minus 2 anymore. Okay, if you leave the absolute value brackets in there, it just gets to be a little confusing. So we isolate the absolute value term, then we set the absolute value term equal the positive and negative version of that other side. That leads you to get values of negative 8 and negative 1. When you sub in negative 8, you end up finding that that is a false statement. You get positive 42 equals negative 42, which is not true. So that is a extraneous solution at negative 8, and thus your only answer here is negative 1. And that is all that we need to cover.